Yes, welcome to this second part about G-code. We want to explain what are this G-code, what does it mean by G-code. So this is a program we have generated from the previous program using CMN 828D. We want to explain what this G-code, line by line. So here, if I was explaining, if you want to convert your G-code to ISO mode, if you're using CMN 808 controller, you want to convert your program to ISO code, you include this line. We call it G291. If it is G290, it is CMN program for CMN. That is for CMN. Let me expand this for CMN 808D. Yes. So I want to explain all this program, what it means. So this is what you call G and M code. G is what you call preparatory function. Then M is miscellaneous function. For you to program this part, I want to put this somewhere. Let me expand this and do this. I want to do something very simple, very unique. Okay. I want to put something very simple. Programming, CNC part program. CNC part program. When you say CNC part program, CNC is what you call computer numerical control. Computer numerical control. Computer means it has the capability of allowing you to input parameters, and then it can process and give you an output. That is the purpose of a computer, because it has a memory. The old machine were using numerical control. They didn't have their memory. They're using what you call punch tapes. So there's a difference between numerical control and computer numerical control. This one, they are using what you call punch tape when they are writing their programs. But nowadays, most machines are CNC. So which means they have the computer capabilities. Yes, they have the computer capability to allow you to input. You're able to input. You're able to input. You're able to. It's able to process, and it's able to give you an output. That is the purpose of a computer. When you say numerical, it's allowing you to use what you call digits. Yes, let's say value or stock digits, value stock digits or numbers. These numbers can be from 0 to 9. Normally 9, we are using natural numbers, 0 to 9. If and then you can also use what you call an address. It has also what you call address. This address can range from A to Z. Those are numerical. Then when you say control, this is just about movement. How can you allow the table to move? Movement. This movement, we are controlling movement in X, Y, Z, A, B, and C. So these are the axes that we normally know. X-axis, Y-axis, Z-axis. Then we have B. B is rotational axis along X-axis. A is rotational axis along X-axis. B, rotational axis along Y-axis. And C, rotational axis along Z-axis. And also, we have what we call I, J, and K. These are the key axes you need to understand. When you say address, for example, a part program, in simple terms, it contains what you call blocks. And these blocks are made of, they contain what you call words. And these words have what you call address and digits. For example, this G90 is a word. Yeah, I want you to understand the G code. G90 is a word. G95 is a word. N1 is a word. G64 is a word. X0 is a word. So when you put many words together, you form a block. This is a block. In layman language, we call it a line. So this block contains words. So this N1, G90, G95, G64, G71, G40, there are words. So if you put these words together, they become a line. We call it a block. But if you put many blocks together, all these are blocks, they become a part program. That is what our CNC part program is. They become a part program. So a word, for you to have a word, it must have an address. So an address like G is an address, X is an address, M is an address, T is an address, D is an address. What do they mean? So address, if you have A, what is the meaning of A? What's the meaning of B? B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. All these are address. Yes? W, X, all these are address. So what is the meaning of A? If you are using a milling machine, normally this can refer to rotational axis along X axis. B can refer to rotational axis along Y axis, and C along Z axis. Normally the spindle axis, the spindle one, they normally donate to using C. Then D can be used depending on the tool diameter or the tool offset. E can be used to mean maybe incremental for thread cutting, depends on which parameter you are using. Then F is what you call the feed rate functions. G is the preparatory. So that's why we call them G and M. So the main part we normally use is G and M. G and M. So this G and M are the one that differentiates or denotes what we call a CNC part program. We call them G and M code, which means G is the main preparator function that are used, and M is the miscellaneous function that are used. Then you need to understand what is H. H can be the tool offset height. Then I, that is the arc length along x-axis. J, arc length along y-axis, and K is arc length along z-axis. If you have done vectors, mathematically we normally have what we call a triad system, X, Y, Z. When you move along x-axis, you have an arc length of I. When you move along y-axis, you have an arc length of J, and when you move along z-axis, you have an arc length of K. So if your machine is G18, maybe for example the plane is G18, which is XZ plane. Normally you will find every program you're using, there must be I and K, which means Y is suppressed because your machine does not support what? Y. But you can customize your machine to read Z as Y, which means it will take you, it will not help you much, because that machine is used by many people, and when people don't customize their machine, they use the standard settings. Then when you come to L, most machine can use this at number of repetitions. In case you are using M98 and M99, or you are using program repetition, you can use L in your program. M is miscellaneous function. N is the sequence number. You see, this N here is the one. The number of line, N1 is line 1, N2 line 2, N3 line 3, N4 line 4, like that. This is the sequence number or sequence line in a program. Then O may depend on the machine. Most of the machines you find here, it is starting percentage, it starts percentage, then maybe O, maybe with a 4-digit number. Yes, 4-digit number. This can be used to denote the operation. Just O and then the 4-digit number. Or the file name. You see the file name here. Instead of writing, for example, mine have written here, design 1, they start with O1 something, O with something, so that it denotes the program file. Then P can denote the program. If you're using what you call cane cycle, this one let me not put it now. We're using what you call cane cycle. I will show you in a simple program. You're using cane cycle. For example, if I write, if my machine I'm using G71, I have U, maybe UR, then G, for example, Siemens 808, G71, then I can put P, maybe Q, maybe U, W, and maybe F and S or T. So this code here, it is denoting the starting with the block for the cane cycle and the end of the block for the cane cycle. Where am I starting with? Maybe I can now say M03, M3, S1 800, and fit rate of maybe, if I'm using fit rate of 40, I'm using G94, for example, G94, 40. If I'm using 0.1, I'm using G95. So this one can allow you to denote the program if you're using turning. These are called Kane cycle. Kane cycle is the program that helps you to simplify the program so that we don't write a long program. It simplifies the programming. In Siemens, you're using G95, sorry, the cycle 95, cycle 94, cycle 71, depending on the controller you are using. And then R is the radius. Radius can be the radius of the part file. For example, you have a fillet, you can use R, or you have the radius of the tool, you use R. Then S is the spindle speed, T is the tool number. For example, you see here, you have T05, that is a tool function. Then U is the incremental axis along x-axis. You are using U. If you are using G91, for example, G90 is absolute programming. That is absolute programming. What is absolute programming? All the reference points are coming from one point. If you are moving along x-axis or z-axis, all references are from one point. But here, if you're using G91, for example, you will find this is incremental. And in most cases, if you're using incremental, you will find that you're using U, W, and UV. They're using something like U, V, and W, which means this U, V, W. U is the incremental axis along x-axis, V incremental axis along y-axis, and W is incremental axis along z-axis. So these are very key when you're programming. They call them word address. These are the word address. They call them word address. We call this as word address. So for you to create a program, you need to combine a word, and this word might contain maybe, for example, G. If I write G90, this is a word, which means it has an address G and it has a number. This address G is like a shelf. You have arranged your file in a shelf. So when you are telling a machine that it is G90, it goes to the G location, address G. Where is the G? Now it is G. I have identified that the address is G from the file. The next G, the code is 90. How the machine, how it was programmed from the backend, it is telling you that G90 may mean absolute. So it is telling the machine that every point you move must have a reference point from maybe 0 that was picked when they were setting up. So it will be referencing that one. So it now take it as absolute programming. If I write maybe x20, it goes to the address x. It knows address x is for axis. That the motor should actualize the PLC should actualize the motor to move with the x direction. But how far? 20. Is it positive or negative? So it knows where it is. If it is 20 positive, it goes towards the positive direction. If it is negative, it goes towards the negative direction. So this is how a machine has been programmed using CNC and PLC platforms to actualize the movement of those, because the movement is done by the motors. They have the servo motors. Others can use servo motors, or others can use there are different types of two motors are used. Servo motors, and another one is called stepper motors. Stepper motors. You can use servo motors or stepper motors. Some of them are used depending on the accuracy of the machine. So this is what we call the G code. So every part has its own meaning. Maybe in our next episodes, I'll come down to a specific machine, because this code may mean different. Not all of them can be the same. For example, here I have G75. Not all machines can combine G75, because G75 may mean something else on all those machines. But remember, the current machines like G75, you're using Siemens 828 or Siemens 840, you may find G75 is for referencing. But if you're using maybe HNC controllers or Fanuc or the old models, they are using G28. So you need to know the right code for each machine, but others may be standard. Like if you come here, not all Fanuc machine can have this, but this one is only for Siemens. So the machine have advanced, the controllers have advanced. Each controller has on its the difference. So you need to understand the code first before you go to the machine. Here I've used SolidWorks CAM to generate a G code. But do I understand it? Or do you understand it? You need to understand the code that you generate so that you're able to rectify and troubleshoot the problem every time you are running a program. Here we have this part, G94. What does it mean? Do you know its meaning? G95. G90, I'm telling the machine that I'm using absolute programming. If I'm using G95, yes, I'm using a few of millimeter per minute. That's why you will find somewhere 0 point. You see this 0 point. It is telling in my machine that I'm using G95. But if you have maybe F100, F40, F10, I'm using G94. Then G64, I'm telling my machine that I'm using a fine accuracy stop. When it's taking a corner or a sharp corner, I'm doing a fine stop. Yes, others can use 604, 601, 602. So it depends. You see, find others are using 604, maybe 601. So it depends to the code you are using. G71. This machine is taking G71 as a metric system. So the metric dimension, because all dimensions here for X and Z are in millimeters, so it is using G71. It's like initializing the code that all the programs here we are using are in millimeters. If you are using inches, it will become G70. That is in inches. But if you are using another machine, you may find G21 or G20. G21, other machines may use G21 for metric and G20 for millimeter, for inches. So you need to understand the code for each machine when you actualize it. And then G40, I'm telling my machine that check in case of any tool compensation, cancel it first. Because somebody else might have put the tool, maybe I'm using tool number 1, and maybe that tool number 1, he had put, or she had put what you call tool compensation. So it will radius compensation. So it maybe take those settings, then it apply on my operation, and yet maybe me have not done that. That's why I'm visualizing that cancel any tool radius compensations. You can cancel it. You have also G41 and also G42. So you need to know which code you use. If you're also using tool noise radius compensation, you have G43, you have G42, and you have G41. So each one you need to know its meaning, how you compensate the tool. Or you have G40 to cancel any gain cycle that were there previously. So each code has its own meaning. And then I go to my tool. I know this is now I've positioned my tool to a home reference. Then you stop the spindle first of all using M01. Then start change the tool to number 6 automatically. Then use offset number 1 for tool offset number 1. G95, and make sure that the spindle speed for cutting maintains at surface cutting speed as 131. Then maximum should be 3000. So each code has its own meaning here. And then it's using G95. If I'm using now the cement code itself directly, I'll be using Psycho 95, Psycho 71. So you need to understand how the code will affect your machine, each code before you take on to a machine. And these are now the all operations. Each one of them has been put. As you see, the first one here is phase. Here is phase rough facing. Once it does rough facing, it comes to phase finish. Same tool. First finish, but first it goes 70 point, then it comes. The next operation, as we had done, is turn roughing. That is outside diameter turn roughing. Then once it finishes, it's using now tool number 1. Change it to tool number 1. I can change here. I remove this. Change it to number 1. Then it goes down. Once it's doing rough, it finishes roughing. It goes to what you call finishing operation. You see, for turn roughing, it's big. Goes to finishing operations. For you to change to another tool here, it is supposed to stop the spindle and then stop the coolant. Stop the spindle, stop the coolant. So you need to understand the codes. What it means. Once it does that one, then it goes down to do finishing operations. Once it does finishing operations, it will come to cutoff. So these are the headers. We call them headers in each operations. These are the comments. So apart programs have headers, have comments, have syntax for like you see this syntax equals syntax. So each operation has its own meaning when you are writing a program. And then once it finishes, you have what you call M30. M30 stops the speed. First of all, it goes home using G75, then it stops the program, and then it winds the start. This is what you call a G and M code, part program. You can write it manually. You see the program is too big. It goes up to number 258. I can renumber this program. Maybe I can come here and then say renumber them. It gives me a new number code. Yes, it goes, you see it goes to 598. It gives me a new number code for each of the operations. And it knows itself. So where it doesn't now need to number, I can remove. All this, I can put semicolon behind. I know I can put semicolon so that the program cannot write. This one cannot, I don't want to run this. So I put a semicolon behind. So this line, it will jump. So that this one is no need. It will jump the program. Then it will go to where it's supposed to cut. So this one now start from here. I can say now start from here. Start from here, for example. Start here or start from here. So this is the program that machine will be reading when it's cutting. Yes. Then you can reorganize your machine. Then you can do what you call a backplot. You go to backplot window. You also do assimilation. This why I say violation. Why? Because I've changed some parameters here, so I don't know. I don't need to do that one. So this is how you can edit the program, and this the meaning of what you call G and M code in CNC. I have used SolidWorks CAM to program my part, edit the parameters, define the machine. You define the machine, you define the code system, you define the stock, you extract the features, you generate a plan so that you can separate between rough and finishing. Then you generate tool parts, the part that the tool should follow when it's cut, you call them tool parts. Then you do assimilation. From there, you post the program. Once you post program, you're able to go the program, then you edit the program. This is how a program is supposed to be done. And this is what's supposed to cut, so that at the end of the day, you have this part. Then you need also to understand the tools. How do you identify the code of the tools? Maybe next episode I'll show you how do you identify the code of the tools. Each code has its own meaning. Thank you for following.